Over here, gentlemen. Thank you.
Testing, am I here? Awesome, I'll give everyone another 15 seconds or so to get situated. And as folks are getting situated, I guess I'll just first say, welcome everybody to what I hope will be one of the many highlights of your DevCon experience. My name is Albert, and I'm delighted to be the host, moderator, and perhaps even provocateur of this panel. Joining me, as has been said, is the one and only gubsheep, Barry Whitehat, and VDog. Three very low information names, taking this zero knowledge thing a bit too seriously, if you ask me. Though I guess Whitehat is a positive piece of information. Like, you know how people in the West, they have these family names like Taylor or Carpenter or Smith or Shepherd. Maybe one day in the digital realm, it'll be full of white hats, but I digress. Today we're going to discuss programmable cryptography and Ethereum. This is exciting for a bunch of reasons. One that stands out is that the four of us convened at the last DevCon in Bogota for a panel that we titled What to Know About Zero Knowledge. Now, I know most audience members didn't see that simply because there's so many more people at this DevCon than even the huge number that was at DevCon LATAM. But as those who did see that panel may recall, I started that panel by apologizing. Why? Because zero knowledge is not just a misnomer, it's usually an objectively incorrect way to be thinking about what is going on with modern applied cryptography. And most of the time when people do quote-unquote ZK, no part of what they're doing is actually in zero knowledge, which we discussed at length last time. That's why it's cool to see how the terminology has evolved in just the last 2 years. We used to call it ZK because we didn't know what else to call it. Now we call it Programmable Cryptography, or PC, perhaps because we don't know what else to call it. Now, call me old-fashioned, but when I see PC, I still think personal computer. So I always do a double take when I read a note by Gubsheep or Barry that says something, something PC. But you know what? Hijacking words such as crypto and zero knowledge to mean things that they didn't mean before, it's basically a tradition at this point. So more power to you if PC actually starts to mean programmable cryptography. That might be your most impressive feat yet. So without further ado, I really have to start here. What are we going to be calling this stuff in 2 years, in 2026 or 2027? And I don't mean like literally try to predict the exact words, because if you knew, then we would already be calling things that. But as Gubsheep alluded to in his talk, and some of you already saw, the term programmable cryptography actually predates even the last DevCon. In fact, Gubsheep, Barry, and I discussed programmable cryptography at EdCon a couple of months before the last DevCon. But we didn't discuss it in the way that we are talking about it now. It was more vibes and intuition than realization and understanding. So really, for any of you, what jumps to mind for what might be the vibes and intuition of how we are going to be talking about and thinking about this in a couple of years? Anyone?
I think we're going to slowly stop talking about zero knowledge proofs and snarks and starks, and we'll just start using the word proof. And like lots of mathematicians are going to get upset, but like that's like fine, right? Because like we made the economists upset by just like abusing the hell out of the word inflation, so let's just do it to mathematicians too. So, yay, we'll prove Ethereum blocks.
I think that the advent of things like FHE and IO is going to mean that the way that people think about programmable cryptography will be based upon those technologies more than zero-knowledge proofs. So I think that we will have things like faith and destiny become the kind of primary vibes that people interface with this.
I think I remember in one of our last conversations that was particularly centered around zero knowledge, we discussed how the idea of what people were calling ZK apps at the time might not be a complete outlook actually on what is possible with this technology. You know, the point of these applications was not the fact that they used zero knowledge, but it was the fact that they actually did something. They brought some new kind of capability that wasn't possible before, whether that's a privacy capability or a verifiability capability or something like that. And I think that, you know, to use a historical example, this is sort of like when we talked about websites as .coms, right? There is some point in time where we talked about the idea of like, oh, this is a .com company, and well, look how that turned out. Eventually, we started moving to things like, oh, here's a browser-based game, or here's like an e-commerce storefront, or something like that. And you know, similarly, we don't call things HTML apps or HTTP apps. We've started to move away from that in the ZK world. I hear ZK apps less and less these days, but I think we're going to also face the same kind of problem with programmable cryptography and cryptography apps. There's not really applications of programmable cryptography. It's about what you do with them. So I don't know if it's going to be something about like the nature of programs that are collectively run by multiple people, or a capability or a thing that happens as a result, but that's where I would think.
Well, hopefully we'll have more chances to chat about this in a couple of years and beyond, and it'll be really interesting to revisit it, because I think one thing we know for sure is that we won't be talking about these things the same way we are now. So, programmable cryptography and Ethereum, or maybe PC and ETH. I know not everyone here saw the talk that Gubsheep just gave, but real quick, in that talk, Gubsheep did a great job teasing the first topic that I really want to dig in with each of you here on today, which is quite simply, how do we think about PC and ETH together? How do we think about programmable cryptography and Ethereum? And I'll start with an even more direct prompt. Is Ethereum a form of programmable cryptography? And conversely, or maybe complementarily, is programmable cryptography an extension, or is it like a spiritual descendant even of Ethereum? Where does your mind jump to? Vitalik, I'll start with you.
Yeah, I mean, I think it's like a similar type of thing, but different. It's like kind of like how I think about like one-shot signatures, which are this like primitive that Justin Drake loves talking about, but they depend on everyone already having quantum computers. But like the reason why that analogy comes to mind is basically because I think blockchains are not cryptographic algorithms in the way that we think of cryptographic algorithms, but they achieve objectives that are similar to cryptographic objectives, right? Like they give you guarantees that like some data has been published at some point in time. They can create systems that can have a guarantee that like someone who wants to participate can participate, which is a really important property of like voting systems, but like really some of potentially everything. They give guarantees of like verifiability of the whole execution process. One cryptography paper buzzword that blockchains basically do is what they call a bulletin board. So blockchains are, like, I would call them cryptography adjacent because they do similar kinds of things, and in some ways they feel like and work like a cryptography primitive, but they also have enough differences from like things like synarchs and FHE, or proofs and FHE and obfuscation that they're worth thinking about as being their own thing.
One thing I also wonder about is there some root node, perhaps, that both programmable cryptography and Ethereum are specific facets of? Is there maybe some more general way to describe systems or the sorts of programs that we might want to run, where you might say, okay, so this property, it's as an implementation detail, something like Ethereum or a programmable blockchain can provide those guarantees. And this other property, as an implementation detail, you can use something like a ZK snark or some form of program obfuscation to achieve that.
Yep. And I think my answer for that is simulated trusted third parties. So this is the idea that you can take a protocol and you first imagine your protocol as running through a trusted third party. So everyone sends everything to Zuck and everyone trusts Zuck and Zuck gives everyone the answers. And then you figure out how to replace Zuck with some kind of construction that has much stronger trust properties, meaning like much less or no need to trust any specific actor. And often parts of Zuck can be replaced by cryptography, but often there are situations where parts of Zuck can be replaced by blockchains.
So it seems to me that like they're natural extensions of each other. That like Ethereum is an implementation of programmable cryptography ideas, right? That it's just based upon. It's contained within.
One thing that has shaped my thinking is that having programmable cryptography not necessarily as this entirely distinct thing or an extension, but it seems to be, and this sort of builds on what both Gubsheep and Vitalik were saying, it seems to enable us to, in some situations, think more holistically about what it is we're trying to do, what properties we want something to have, and I mean, 2 is greater than 1, quite literally, and sometimes that additional flexibility, I think, has really helped unlock how we think about things, even when it wasn't maybe strictly technically necessary for that. So I think some of these second-order effects, which are always harder to predict than even the already very interesting, like literally what can like X versus Y do or not do, is going to be a real big part of the story as we continue to explore. One thing that's also become abundantly clear, at least to me, and I imagine others here would agree, is that programmable cryptography, or at least what we're calling that right now, and Ethereum, I'm pretty sure we're going to keep calling it that at least for a while, those together, the whole is greater than the sum of the parts. These are very complementary, and we're really going to see, I think, a really beautiful synergy, or choose your buzzword here, in the years to come. But for this kind of next section of this conversation, what I'd like to do here is put on this provocateur hat, because if nothing else, it would be entertaining to me and hopefully to some of the folks who are here with us right now. And it's, as moderator, it is my Devcon given right to seek amusement. So I was thinking, what's the best way for me to provoke here? And let's start from the basics. If you want to provoke, you can be reductive and simplistic. So I'm going to be reductive and simplistic, and I'm going to say there's 2 buckets here. There's the programmable cryptography bucket, and there's the Ethereum bucket. So I'm going to start with Vitalik as the, I guess, representative of the Ethereum bucket. Vitalik, what would you like to see the quote-unquote programmable cryptography folks do differently, like maybe consider approaching or prioritizing differently, such as potentially placing greater priority on making things that people in the Ethereum ecosystem can use more immediately?
I mean, I think in Ethereum this year we've definitely seen a big shift from like just building demos to trying to build applications that really work for regular users and that work at scale. And we've seen like plenty of beautiful examples of this, right? So we've seen Farcaster and Polymarket and the usual ones, DDocs, decentralized encrypted Google Docs alternative. We've seen all kinds of different things, and blockchains becoming much cheaper and more performant has definitely been a critical part of that, right? And I think programmable cryptography has been getting to the same transition, right? Where like dev tooling around Synarchs has gotten vastly better and just keeps on improving every year. And I think actually it is time to like really have like at least some portion of that community like approach more problems with I guess a product mindset, right? So like one example of this is we've seen this year ZK email, right? And like basically turning email addresses into Ethereum addresses, where if you have an email address, you can generate an Ethereum address that can only be controlled by that email address. Like, that's powerful. That's like a Web 2, Web 3 integration. That's like a bridge that allows like existing like Web 2 users to start using Ethereum applications in this like very direct way that allows you to then just like swap the email address out with anything else later. And I think there's like equivalents of that in ZooPass. There's equivalents of that in the whole like other like ZK identity wrapper space. Like basically, like really get into that gear of like actually building things that are like next year like everyone here is going to use and like use voluntarily, and like not just because the high priests told them that this is like the aligned thing to use.
Gubsheep, I'm curious for your thinking on this, because you're obviously not against the idea of building things that people would find useful. And I also think it's been fascinating to see how Ethereum, not just technologically, but, well, for lack of a better way to describe it, the values and philosophy of Ethereum have been very influential and beneficial to you. So when you hear things like what Vitalik was just saying, what else comes to mind? Like, why is it, I'm going to be, again, reductive deliberately here. Why is it not as simple as figure out the thing that a lot of people can use and go and build that? Or is that what you think you are doing?
Yeah, I think ultimately it has to be, the answer to this sort of thing has to be a yes and I kind of favor an approach that takes at least three things into some kind of balance here. So on the one hand, we absolutely need to be building things that touch real users at the end of the day, that are going for adoption maximization. At the same time, I think that I've seen with myself and projects in the 0x Park orbit also fall into the trap of basically spending a lot of time building one feature, maybe not even one product yet, but one feature. Or you might see, when the technology is in really early stages, entire companies, well-funded companies emerge to build one circuit to do one kind of identity transformation or something like that. And I think it's worth taking a step back at times, and we do need to have that kind of feedback loop out in the world, but at the same time balancing that with the approach of, well, okay, how can we always be thinking about how to level up our capabilities and generalize and not lock ourselves in? We've had a lot of experiences where we'll have basically one neat thing that we want to do. Maybe it might be some kind of proof between some sort of identity source and some kind of application that we could imagine using that identity source as authentication. And we might put a couple of engineers who might spend a couple of weeks or even months building the circuit that takes the incoming data schema, converting it, running it through a different proof system and getting some output. And then we might realize after deploying that actually, this is slightly different, or this is maybe even like completely off from what people in the target domain actually want to see from the data in the source. So that's where a lot of my thinking in the last couple of months, maybe a year or two, has started to go around like, well, maybe we don't yet have a complete mental model of what's going on. And before putting all of our eggs into the basket of maximizing for a particular kind of adoption, if we can build systems that allow us to flexibly iterate and experiment, then we can sort of take a balanced approach. And then one thing I'd love to hear from Barry as well is there's at least one more kind of branch that we need to be pursuing simultaneously, which is, well, what if it's not just the mental models about existing technology that aren't there yet, but what if it's the existing technology is completely wrong and something like obfuscation or functional encryption is actually going to solve a bunch of problems that are obstacles for programmable cryptography even reaching any kind of adoption. So some combination of these three approaches in balance is hopefully the way to go. I'd be curious to hear from Barry, though.
So I spent some time thinking about why the first blockchain application was currency. I thought that there was like another world where we could potentially have had a reputation system become the first major thing to use that technology. But I thought about it and I thought that was reasonable for a while, but now I don't think that that's reasonable anymore, because I think that like currency is inherently freer right? Because you can just transfer currency to other people and other people can receive it from you. There's no real barrier to entry. But if you had a reputation system or identity system, it's harder to transfer reputation. The other major problem is that like currency is able to like interact with the rest of the world very easily, right? Because you can transfer from one thing to another. But like, how do you do reputation and identity systems? How do you use them? Well, it ends up being all about like going to places or being allowed, authenticating to do something. And I feel like this is not a good like business to be in. Like this doesn't seem like a good place to spend our energy because it fundamentally makes systems that are better at excluding people, or it's a more efficient way to exclude people. One thing that like I've looked back on the last year and thought like maybe that was a bad idea was the focus on ZK around ticketing and things like that. Because I feel like making, like there's these arguments that I've heard before that like if you make it easier to KYC people, people will just get KYC'd more, right? Or maybe KYC is a bad example. If you make it easy to check if someone's over 18 or not, then people will just have to prove they're over 18 if they want to buy eggs or something, right? So like this is my general concern about like going in the direction of like we should just go to production right now. And like this line of thinking has made me feel less excited about building things with zero knowledge proofs and more excited about building things with more like an interactive technology like FHE and IO and things like that.
So that segues nicely into, I wanted to dial up the provocateuring a bit, and I'll start with gubsheep. I have one for you as well, Vitalik. For gubsheep, I guess one lens with how you, 0xPark, and others have been approaching PC, that it could be a bit of, let's call it a skeptical lens, would be that it sort of kicks the can down the road for figuring out the thing, which we certainly all agree is some version of impacting people in a positive way. And I'll even get more specific. One thing that we've discussed is there may even be these kind of correct by construction-ish elements to what's emerging in terms of how this whole programmable cryptography thing works. There's some really interesting stuff there, and actually, if you ask me, I kind of believe that we're going to feel like there's directionally correct by construction things, kind of like how the theory of computation was, or even just like a Turing machine, feels almost correct by construction once you start to really appreciate it, even though it's not obvious at all at first why you should have this tape and these symbols and that should be like the way to think about pretty much all computation, or at least a very remarkably effective way to think about all computation. And yet at the same time, I'd say the Turing machine isn't actually a relevant concept a lot of the time. I would say the vast majority of the time. You know, I've been a professional software engineer. I think it's very interesting, and yet it pretty much never mattered. You could say maybe that's because we got multiple layers of abstraction later or other things. I mean, I think it's somewhere in the middle there. But yeah, that's kind of I want to hear your response to that sort of prodding.
Yeah, so one thing that's been really interesting for me to observe over the past maybe 5 or 6 years that I've been building various things with some of these frontier technologies is this idea that it's been a process of constant generalization. And what generalization gives us is leverage. So to give a couple of examples, this one actually comes from something more adjacent to Ethereum than programmable cryptography. When I started working on Dark Forest in 2019, at the time, the idea of building an on-chain game using zero knowledge seemed kind of like this really interesting or clever trick. We were using ZK in this one very particular way to achieve one very particular kind of interaction on chain. And we built this application using some bespoke patterns because there wasn't any model for this idea of an on-chain game or an autonomous world. And I remember thinking back then, one of our big inspirations for Dark Forest actually was this game called EVE Online, which is one of the oldest and largest MMOs with sort of the most interesting player activity, emergence, longevity, all of these things. And I was just thinking, man, it would be so interesting if someday we could get to a world where EVE Online or something of that kind of complexity was actually running on chain. So I ended up spending about 2 or 3 years building Dark Forest and continuing to just add to the specific Dark Forest circuits, optimizing the specific Dark Forest smart contracts, and adding in all these features. And at some point I met my co-founder at 0xPark, Ludens, who, what he did was he took a look at how we were doing dark forest, and he basically built a mental model for what was really going on. So he kind of built this mental model that was expressed both in software and abstractly, conceptually, for this idea of autonomous worlds and autonomous worlds infrastructure. And they got to work building Lattice and Mud and Redstone and all of these tools. And suddenly it became possible to build not only the next 10 dark forests, but also something like a dark forest that was actually 100 times more complex and interesting, and actually had a shot at getting to hundreds of thousands, millions of users. And actually today it's really interesting. We've closed the loop on this over 5 years, and Eve recently announced that they're going to be building their new game on Ethereum-based technology. So when I think about this sort of question, I think not necessarily like, well, how do we make the perfect abstraction of something like lambda calculus, but how can we build a more general mental model that actually gives us leverage, where in 5 years, because we're thinking about this the right way and we're building the right abstractions, we can actually access those millions of people who might want to use this technology.
That leads nicely to the prodding that I want to throw your way, Vitalik, which my, I guess, straw man counterpoint to the PC should be doing more for Ethereum people today, it would probably be something on the lines of, this is not as generous to Ethereum as I think it should be. But let's just say that Ethereum has made amazing strides, but it still feels a lot like this magical island where the physics works differently. But it only works that way on that island. And there are bigger and better bridges to get over there, but the island is still kind of pretty far, and the bridges are still pretty narrow. It's almost like a bizarro Burning Man, right down to the traffic and just how accessible it is, where it's like accessible, but it's not that accessible. And Ethereum does already clearly have a very big ecosystem, with people doing amazing work on all sorts of fronts. So arguably what Ethereum needs is efforts that kind of aren't just stacking on top of those prodigious existing efforts, but taking this, say, complementary approach, bringing, like a phrase that comes to mind is bringing snippets of Ethereum physics back over to the main continent, to accelerate like how these different worlds can synergize and synthesize. And I'm curious for what jumps to mind when you hear those kinds of thoughts.
Sorry, I'm trying to think of. Can you rephrase the question again?
Yeah, I think what I would boil it down to is, reductively, you could say if programmable cryptography works backward from what Ethereum needs, it may be more marginal in terms of how it can bring what Ethereum really cares about to the world. And that would be one lens that differs at least slightly. I think, again, the real answer is you can do both, but I want to be reductive for the sake of argument.
Yeah, I mean, I think ultimately, it makes perfect sense to have people that are developing the algorithms, and algorithms, I think, are inherently a very general purpose thing. And there are sometimes optimizations that you can make for some use case, but then as we've seen with proofs, right, everyone is just moving to doing proofs over RISC-V, and once you do that, then it's any optimization is basically almost equally valid for any use case, right? And I think for fully homomorphic encryption and obfuscation, a lot of the surrounding primitives, there's a big elements to them, which is just general purpose, and it's inherently something where you build infrastructure that either almost any use case or at least very large classes of use cases need, right? And there's one group of people that's very good at and very naturally inclined to do that, and then there's a somewhat different group of people that are more applied applied programmable cryptography in Ethereum people. Sorry, I just realized applied programmability in Ethereum spells ape. It's fine. So you have the applied programmable cryptography in Ethereum people, and then you might realistically end up having several other applied programmable cryptography communities pop up that care about other kinds of problems, and to me that's a natural kind of diffusion. I mean, just there's lots of Ethereum communities that like don't really think much about programmable cryptography, but then even those communities, that's like once the general purpose stuff gets good enough, then they end up using it whether they realize it or not, right? Like anything that's on top of a validity rollup, you know, we're not saying ZK rollup anymore, they're validity rollups, that is a user of programmable cryptography, but they just like don't see it at all. And so I expect we'll see a lot of that.
Well, for the final portion of this talk, which you guys both sort of hinted at, I want to dig into the future, which I'm sure everyone is interested in particular through the lens of obfuscation. But before we do that, and I really only want to take like 2 minutes for this because I do want to make sure we have a chance to explore that topic well, I want to give everyone like 90 seconds to one, get another frog, because I know you guys want to do that. And maybe even scan a neighbor's frog if your neighbor happens to have one. So everyone, feel free to take a moment to actually pull out your phone, search the swamp, and while we're doing that, Gubsheep, I'd love to hear some quick thoughts on what is this whole frog crypto thing about anyway. We saw a glimpse of it at DevConnect in Istanbul last year. Even just like why frogs, but you know, what else is there to it that you might want to say while we have everyone here?
Yeah, so some of you may have noticed the frog hats that have been popping up, kind of like mushrooms, around the conference, or some of you might have swung by the Programmable Cryptography booth downstairs. Frog crypto came out of being originally a pun on one of the decentralized sort of DevConnect events we ran last year in Istanbul called Prog Crypto, and we sort of realized, I think at some point someone either like typoed it or you know, some part of the P on some signage fell off, and we're like, oh, Frog Crypto, yeah, maybe that could be kind of like a mascot or something. So the idea here is that, you know, these frogs are almost a delivery mechanism for some of the base sort of data of programmable cryptography. This year, what you can do with them is you can collect them on ZooPass. So you can go to ZooPass, press the little frog button, and start collecting a frog every 15 minutes. And what that frog is it's basically an EDDSA signature that's really easy to make ZK proofs about. And various developers have been building games on top of this idea of making ZK proofs about your frogs. One of the new things this year is that you can also scan other people's frogs by, you know, holding up your phone and scanning the QR code and sending them a frog request. This allows you to add them as a friend in Frog Social. And what those frog requests are those are self-issued attestations to other people who are also participating in this. So what we're essentially doing here is we're building this social graph actually of thousands, or actually I think as of maybe a few hours ago, we might have crossed like 10,000 frog requests that have gone out between different members of the community that we're going to be able to start making all these kinds of social graph proofs on top of. So you can imagine being able to do these reputation proofs. We're already starting to run into a lot of issues with Sybil attacks. So, you know, it just goes to show that cryptography preventing these sorts of social attacks is definitely, there's both like a theory of it, but also a practice to that. But we're excited for this to be a sort of sandbox for people to experiment with the various kinds of functionalities.
Cool. Well, I recently got an obfuscatode, which I was very excited about. And speaking of obfuscatode, let's dig into obfuscation because, and the reason for this is, I can't really articulate this well, but it feels a bit like the quote-unquote next thing. And what I mean by that is, it's a thing that we do understand technically, but I think we're still figuring out how to think about and reason about it in other ways. Kind of like how we technically understood ZK long before we really started to have some of these now seemingly basic conceptual breakthroughs, even like single player versus multiplayer and other things of that sort. There's so many different lenses here. We can look back at the arc of how things have developed and how your past predictions have gone. You can look forward. You can just share new insights and realizations. I'm going to start with you, Barry, because this is something that I know you have been digging into a lot, and you've been one of the primary sources for me to begin to get this sense around obfuscation in the way that I'm describing here.
Yeah, so I'm very excited about the potentials of obfuscation, and it's like part of me, okay, so the way to think about it is that you, like Vitalik was saying earlier, you can imagine that you have this like trusted third party that you can actually trust, and that you can just ask them to do something to help you. And with zero knowledge proofs, they can help you to verify computation, but they can't do anything else. And with MPC, they can do like multiple people's computation, but they're not able to, they have this interaction layer. But with IO, you're able to have this like no interaction required. Basically, you put something in and you get the answer out. And this seems to me that like we're getting so close to what like an actual trusted third party could do that it seems that we might be getting towards the end of cryptography. That like we're at the point where like once we have this, it's hard for me to imagine like what else we could actually have. Because if we could have something else, it would have to be something that like an actual trusted human would not be able to achieve. Like there is a couple of things that IO can't do, like data availability and one-time signature kind of stuff. They can repeatedly, you can force them to do things repeatedly. But like it seems that we're getting to the end of the land. That like, and I don't know what we're gonna do once we get there.
I mean, I think, once if we actually get to the end of the line, which I do think obfuscation in some sense is in a certain sense, because it basically does let you like simulate any trusted third party, with the exception of this, like you can't, that you can't ensure the non-reverting property, and that you can't ensure, well, you can't like do anti-censorship. But like once we get to the end of the line of like base layer technology, then I think that's the beginning of the line for so many more things that get built on top of it, right? And I think this is something that we see in lots of other fields, right? Like there's definitely lots of things that we've seen that have basically approached some kind of optimality, like multiplication. We know how to do it in n-log n now. I mean, and okay, fine, the algorithm that technically does it in n-log n only actually becomes like remotely efficient if you're multiplying like quadrillion digit numbers, but like for everything else we have n-log n, log n, and like do you really care about the difference, right? But then it's like when you have like these fast algorithms that enables lots more stuff in higher level fields to be built on top of it, right? It's like if Fourier or fast Fourier transforms did not exist, then there's an entire class of zero knowledge proof algorithms that would just not be possible, and we would not even be talking about this field in the same way today, right? And then on top of that, then you figure out, once we figure out how to make any trusted third party trustless, and then once we get that down to, there will be a period of like at least a decade where we figure out how to get everything down to the lowest possible level of overhead, right? And then once you get past that, then the question is like, what are all of, like every time you make an optimization, what are the new things that you can build on top? And then I think even after you're done the optimizations, you can keep on thinking of new things to build on top. Like that's, I don't think it ends.
Yeah, one thing I think about as well is this idea of, right now, one way we can think about obfuscation is as a drop-in replacement for a trusted third party. And that might enable us to give stronger, security or confidentiality or other kinds of guarantees on top of things that we use trusted third parties for today. But an interesting question for me is, in the spirit of one prompt that we've sometimes discussed is this idea of like, what if obfuscation is not the end, but it's really just the beginning? Like, what is it the beginning of? I suspect that, similar to I have a similar prediction on things like Ethereum and other kinds of cryptography. Once obfuscation or these kinds of technologies become ubiquitous enough, we enter a totally different state of what the internet looks like and feels like. It's not just the internet that we have today, but servers are replaced by these more, trustable or verifiable or confidential services. We actually go from like solid to liquid or liquid to gas in terms of what it even means to be interacting digitally. Now, I don't really know how to think about that. I feel like, I know Barry and Vitalik have some ideas on some of the crazy stuff that might happen there. But that's a prompt that I at least think is interesting to consider.
Yeah, I love that. I'll build on that. It's really hard right now to imagine obfuscation being like virtually free, given that we've barely begun to understand how to even do it, and then the overhead is significant, to say the least. At the same time, you tell someone 100 or definitely 200 years ago that the cost and latency of sending a message, and not just a message, like let's say HD video, halfway around the world, would go to basically zero, I think that would have been even more unfathomable. And so we've seen that these things happen slowly then quickly all the time. And while we've got a lot of heavy lifting, grunt work to do, I do think it's valid to take a moment and say, what jumps to mind as you start to imagine the currently pie in the sky feeling, hey, this is everywhere, this is the beginning, intersections or overlaps with other technologies or other aspects of society. I know this is something you guys have mused about at various points, so curious to hear what jumps to the top of the mind for you here.
So my prediction for the future is that in 20 years there will be like what we would call today a religion that's based upon indistinguishable obfuscation. At the start of the panel I talked about like destiny and faith being the like vibes of the future world, and that's my prediction. I also predict that one member of this panel will become a member of that religion, or that, like, we won't call it a religion, that's a secret. Yeah, like we won't call it a religion in the future, but like today, that's what we would see it as.
Yeah, that's fun. So it's like how Beth Bezos does his thing about thermodynamics, and we get to do our thing about obfuscation. Yeah. Yeah, okay, let's see. Yeah, far future. I mean, well, get into BCIs, and then you get trustless two-way telepathy. Yeah, do you want to like upload your thoughts to Facebook? Probably not, right? But do you want to like have deep communication that involves like sharing thoughts directly with other people? For some specific other people, like sometimes possibly. So that's one of those spaces where like if you don't do it with cryptography, it feels like it's almost default dystopian, but if you do it with cryptography, it feels fine. And like actually having cryptography up to the highest possible standard of usability and just like drop-in replacement power once that stuff becomes available seems like it would be really powerful. Right, like the level you want to get this stuff to, it's like, I think for me the analogy is how our like internet bandwidth is at this point so good. People just like send pictures as a way of saying things that they could have said in like 5 words just because sending the picture is faster. And like to someone in 1980, this would have seemed like batshit insane. Like, no, why the hell are you like voluntarily incurring like 100,000x inefficiency, right? And like these days, of course, we figured out how to cut the inefficiency off of our like lower level bandwidth by a factor of more than 100,000. And so that's like doing that is like actually totally fine, right? And so I think what we want is we want to get the overhead numbers low enough that the question flips from like why programmable cryptography to why not programmable cryptography, and we get more things proven, FHE encrypted, and obfuscated as needed by default.
Yeah, one other thing that I think is a really interesting future to consider as well is this idea that programmable cryptography, or whatever we'll call it in the future, provides an alternative lens on digital agents of the future. So I feel like a lot of the dominant narrative today centers around this idea of, LLMs, we anthropomorphize them, they speak to us in natural language, those are going to be the digital, that's what the digital agent of the future looks like. But there's a very different concept that you get if you take the idea of something like a smart contract, or what we call a cryptomata. You could kind of imagine an obfuscated program running inside of a smart contract with one-shot signatures to its logical conclusion. This might be cryptography's dual to something like AGI would be a cryptomata. And what the cryptomata is rather than this sort of digital god figure that's got its identity that's bearing down on you, it's almost like a force of nature, like a Gaia type thing that pervades digital cyberspace, where wherever I am in digital cyberspace, I can kind of interact with this underlying fabric style thing that just permeates across digital reality. So as one example here, I sort of think of DNS as a very, very primitive version of this kind of digital agent. Wherever I am on the internet, I can reach out to DNS, and it behaves in this very well-structured and useful way that creates some sort of global context. Now imagine taking that capability and ramping it up 100,000 times. Imagine giving that intelligence. That's a very different concept from something like GPT.
So I feel like we're already getting a snippet of this, but we have like a minute and a half left. And so I kind of want to end where we began, but instead of what words we're going to be using in 2 years, what words are we potentially going to be vibing around in 20 or 50? What jumps to mind?
I mean, I think like the words will just become more basic, right? I think it's like, you know, during the like academic like pedant era, obfuscation is called IO, and distinguishability obfuscation, and you put the I lowercase, but then of course that like confuses the hell out of everyone because that's input output. And then I'm expecting we'll just call it obfuscation, and then I expect 10 years after that we'll give up on that too, and people will just talk about encrypted programs. So I think we'll just like start talking about every concept in language that just makes it feel like something much more and more banal and just like something that's a part of life.
Yes, one for me is, as Barry and Vitalik have been saying, if IO gives us all of the powers of a fully trusted third party, then that means that anything further along this trail would have to give us more than what a trusted party or an actual human could do. So there's probably some crazy sci-fi tech out there that goes far beyond what we think of today as cryptography and blockchain, but is a natural descendant. Maybe for the complexity theorists in the room, maybe we'll ascend the polynomial hierarchy or do some crazy stuff with computation. I think quantum is probably like the most immediate thing that's in front of us, but what's after that? I mean, we don't know.
I think that something will happen similar to what happened when we invented money, that we invented all these words like justice and like, so I believe that those will become the like default words that we'll be using in the future. Like honor, justice.
All right, gentlemen, thank you so much for that exciting panel session. Let's give them all a big, big round of applause. Thank you. Now, we're not done yet. We're not done yet. We've got some Q&A coming up, and we're going to show it on the screen. Ladies and gentlemen, let's go. Well, 8 votes for the top question. Two-party MPC could do everything that FHE promises, just much cheaper. Now, in the next 10 plus years, and likely ever, are we victims of a VC-powered story takeover? Big question. I'm not sure who wants to answer it, but Albert, I'll pass it over to you.
Yeah, I'll start. If there's a VC-powered story takeover here, that'd be very interesting. The whole point of that is the money. Where's the money? Are you guys not sharing something here with me? And what's going on?
No, like 2PC is limited to 2 parties though, right? And you want to have like multiple parties. So like that's one of the reasons why FHE is more interesting. Like both are interesting. The other big problem with MPC is the interactivity requirement. That's also a problem with FHE, and that's why IO seems to be the most interesting thing for me right now.
Great. All right. Anybody else? If not, we can skip to the next question. That's good. I also want to know where's the VC money in programmable cryptography. Hopefully coming soon. Ladies and gentlemen, next question has, I believe, 7 votes. The second question on the screen. Will the PC allow smart contracts to have signing functionality similar to EOA? Who'd like to take that question? Anyone can. Vitalik?
Yeah, I mean, I guess it depends what you want out of signing functionality, right? Because if you want just like the ability to express authority, then like you don't even need any kind of programmable cryptography, right? You just like use Ethereum's built-in call mechanism already, right? The one thing that obfuscation does that is interesting is that it gives you a snark where the algorithm for verifying the snark just is verifying any kind of signature scheme. And like that comes at the cost of requiring a trusted setup, but that does basically mean that you have like zero-knowledge proofs that are extremely cheap and like that are only as expensive as like just a signature, which is extremely cheap in the current world, and then in the quantum world, like the quantum resistant ones are somewhat more expensive, but it's I think still interesting. Thinking about like the other thing that you could do, like the thing that you definitely kind of can do, but with difficulty, is if you start talking about not signing, but like encrypting and decrypting. Like what if you want a program that has a secret that it releases under smart contract conditions. And the challenge there is like the way that you would do it is you would have an obfuscated program that releases it if it provides a proof of blockchain consensus and that like has like some finalized root, and then the finalized root like shows that some particular condition was met, and then the program only then would would actually output the secret. The challenge with this is like basically like one is vulnerability to 51% attacks, right? So if 51% of the stakers come together, they can privately extract the secret without ever like actually being slashed. And one mitigation to this would be to like add a tiny amount of proof of work in, like maybe like 1% proof of work, and then extracting any individual secret would cost like at least a few $1 million. So there's some mitigations there, but like, and so it's like on the bound, it's like possible, but with caveats, which I think is interesting.
Thank you, Vitalik. Possible, but with caveats. Let's go on to the next question. Now, this one's fun. I think Gubsheep just mentioned this very briefly about AI and programmable crypto. The question at the top is, how much autonomy should AI be allowed to have to interact with programmable crypto? Who'd like to take it? Or Gubsheep, can I pass it to you?
Yeah, so one idea that I think is very exciting to revisit from the last 20 years that relates to this question is this idea of the semantic web. So for those who weren't familiar, this was the idea that maybe we could have an internet-wide mega project to take all of the data on the internet and make as much of it possible machine-readable, semantically consistent with other data, make it so that machines can talk to each other in some set of data schemas that are universally interoperable. And I think, you know, the semantic web didn't work out for various reasons at the time. One was the verifiability of data is something that we just, you know, we didn't really have the technology to have programmable verifiability back then. But now that we have programmable cryptography, we can imagine a world where, you know, the current version of autonomous digital agents, which is AIs and LLMs, which are an upgrade over the bots of 20 years ago, can speak in programmable cryptography to each other. So programmable cryptography almost becomes like a language or communication stack for these digital beings of the future. So I'm all for AI being able to interact with programmable cryptography. I think there's like even wilder intersections here, but
one thing I want to add here is programmable cryptography is not like entirely orthogonal to the idea of autonomy, but I think it's more in that direction. Like the question of how much autonomy, what we call AI, because honestly I don't think we know what else to call it right now, that is largely in a different sphere. And what's interesting about programmable cryptography is it's sort of second order, like depending on the autonomy level of AI, programmable cryptography may really shape the implications around it. Like will something decide that it wants a semantic web or those types of things? But yeah, the elephant in the room is like, will AI be very autonomous and will it have, you know, very serious implications? I think that has some maybe interaction with what's going on here. One could say that it certainly has interactions with blockchains. But I just want to highlight that programmable cryptography, at least at a simplistic level, I see as largely like something that's complementary to the autonomy question itself. I'm curious if anyone else wants to chime in on that.
Yes, no, no. All right, he shook his head, so I'll take that as a no. But no worries. Thank you for the answer as well. I think that's quite comprehensive. Autonomous AI, that's going to be quite an interesting future to look forward to. Let's turn our attention to the top voter. I think this is 12 votes, the most I have ever seen so far in any of the sessions. If Ethereum was built with programmable cryptography in mind, rather than Bitcoin with smart contracts, would it have been built differently?
I mean, yes, with like a lot of tiny details, right? It's like if Ethereum was built with statelessness in mind, the gas cost structure would have looked very different. The tree would have looked very different. Lots of things would have been like designed around stateless proving. And for snarks, it's like basically similar. Like gas costs of hashes would have been higher. We probably would have considered just like using Poseidon right from the start, I think. I mean, when I started in Ethereum, I was definitely like in a YOLO-y mood. I probably would have just made Poseidon the hash function. what like there's just a lot of like little tiny decisions that would have been different. I think the core of like being a platform that has accounts and that has transactions and that has a VM probably would have been the same.
All right, thank you very much, Vitalik. Appreciate the insight. We got, I think, 1.5 minutes, so let's try and fit 1 or 2 more questions. Will devs using prog crypto risk punishment like Tornado Cash devs? How to dance with compliance? A bit of a loaded question. Would anyone care to try?
Well, I'm curious what Gubsheep thinks, because this is his problem, not mine. But in all seriousness, I mean, I think that, look, there is precedent. Like, cryptography, in a very simplistic sense, was, you know, there were efforts to try to ban it in the 90s, something we completely forget. Now it's like, you can't not use cryptography to surf the web. Like, no browser will basically let you do that without a lot of pain. And so, I think that the financial aspect of Tornado Cash was obviously a significant part of that. I think that what's fascinating about programmable cryptography is we literally have a precedent that cryptography is everywhere. You all use it every single day, generation 1 cryptography, in the form of like HTTPS and other things like that. So I think there's a very broad surface area. There's always ways to do things in ways that cause these effects. But I think the key thing to keep in mind is that the surface area here is very, very broad, and that's what makes it exciting.
Maybe.
Yep. Maybe it's one quick sentence on it. Yeah.
Yeah, I think that one thing that I think about here is it's about how we really sell the capabilities of the technology. For example, one thing that you can do if you're talking with someone who might be very skeptical is, do you talk about interoperability or do you talk about subverting nation states? And you can talk about interoperability in that conversation. You know, that's sort of what this kind of thing is all about. This is something where we are testing the powerful capabilities of programmable cryptography. You know, it just depends on what foot we put forward first. So.
All right, thank you very much. As the music's playing, that's our cue to say goodbye. Ladies and gentlemen, let's give our speakers another big round of applause.